is the video lesson for Chapter 6, Section 1. Okay, so 6.1. So in Chapter 6, there are two easier sections which we'll do video lessons on. That'll be 6.1 and 6.2. Then 6.3 is a little bit more in depth, so I do that one in class. That way we have more time to spend on it since you watch these at home. Alright, so Chapter 6, we're starting on the periodic table. Y'all, the more you can understand the periodic table, the better it makes the rest of the year. The periodic table is the biggest cheat sheet I can give you, but you have to understand what it means and how to use it. And so that's what we're kind of learning in Chapter 6. Alright, we already learned kind of how periodic table is set up like electron configuration from Chapter 5. We kind of learned about the S, P, D, F sublevels. Okay, so now we're just going to learn a little bit more about it, and with every chapter we kind of unlock more secrets about the periodic table. Alright, so let's start 6.1. So 6.1 is about the basic organization of the periodic table. So chemists use the properties of elements to sort them into groups. So a group is a column. Okay, so these are groups. A period is a row. Alright, so think of it this way. An easy way to remember that is, how many class periods do you have? You have 7. How many rows are on the periodic table? 7 rows, 7 class periods. Okay, you don't have 18 class periods. That would be ridiculous. Okay, so 18 groups. Groups are columns. 7 rows, 7 periods. Okay, and so what this is saying is that elements in the same column have similar properties. So these elements right here would be similar. These would be similar. These would not be similar because they're in the same row, not the same column. So, a long time ago, Mendeleev is credited with creating the first useful periodic table. Now, he's not the first person to ever think of organizing the elements, but he was the one who's credited with the first useful periodic table, which meant it must be worth something, as in other words, we can figure out things from it. So he decided to arrange the elements in order of increasing atomic mass, and so he also put elements with similar properties in the same group. So he ordered it by mass, and then he kept groups or elements with similar properties in the same group. And so his periodic table kind of looked a little something like this. Now, I can barely see this, and I'm standing this close to it, so I know that you're not going to be able to see it in the video. But in his periodic table, he literally has some question marks, okay? But he has numbers next to him. So in other words, like after zinc, he has 2 question marks, but he has masses written next to him. So in other words, what he was doing was he was saying, okay, I know we don't have an element here yet. We haven't discovered one, but I think there is going to be an element that has a mass of 68. So in other words, in his periodic table, he made some predictions about elements that hadn't been discovered yet. So like I said, by the way, here's a picture of him, obviously incredibly attractive. When he finished, there were blanks in his periodic table. But since he arranged them based on properties, he predicted properties about those elements. And a lot of times he would predict the masses that hadn't been discovered yet. Now, you can make predictions all you want. Like, for example, sometimes in the weather they say it's going to snow. Sometimes it does, sometimes it doesn't. When you get your predictions wrong, you lose credibility. Well, the thing is, when they did finally discover the elements, his predictions were right. And y'all, they weren't just a little bit right. He was predicting the masses of these elements with just decimal places being off. Okay, it wasn't like he predicted, oh, it's going to be 200 and it was 175. It would be he predicted 175.04 and it was 175.05. I mean, he was incredibly, incredibly close. And so since he could make those predictions just based on the setup of this periodic table, they determined that this is useful. And so that's kind of what we were leaning towards. Okay, but now we have what's called the modern periodic table. The modern periodic table is still incredibly similar to Mendeleev's, except now we have it in order of increasing atomic number. Now, I know you can look at the periodic table right now, and you can think, oh, well, it looks like it's in order of increasing atomic mass, but there are some tiny little exceptions. Like, for example, if you're looking at the periodic table right now, look at the mass of Te, and then look at the mass of I. That's number 52 and 53 on the periodic table. Te is 127.6. I is 126.9. That is not an increase, that's a decrease in mass. Okay, and there's lots of little differences like that. So you can't tell me modern is in order of mass. It's in order of atomic number. And atomic number, of course, is the top one. So elements in the same group still have similar properties. That's why our periodic table is arranged the way it is. Elements in the same period, so periods are groups, have a repeating set of properties. This is referred to as periodic law. So real quick, y'all, I'm going to give you an example of periodic law. It's completely made up, but it'll help you understand what it is. But I got to click back to a periodic table. All right, so let's just use this periodic table right here. Now, I know that they're all colorful right now, but we're going to change the colors. Okay, so hopefully you already know the order of the rainbow by Roy G. Biv. So you have red, orange, yellow, green, blue, indigo, violet. And so what we're going to do is we're going to pretend like those are the properties of the elements in the same group. Okay, now these aren't the real properties, but these are just pretend so you can understand what periodic law means. So let's say that this element is red. We're going in order of the rainbow. All right, this element's red. Since all these other elements are in the same group, they're going to have the same property. So let's say they're all red. Okay, so all of these are red. What's going to come next in the rainbow? Orange. So all of these are orange. Then we have yellow, green, blue, indigo, violet. So the elements in the same group, all of these, they're going to be orange. All of these are going to be red. They have similar properties. But let's look at what happens as you go across instead. So if we're going across, we would get red, orange, yellow, green, blue, indigo, violet. So is it the same across? No, the properties are not the same. But let's look at what happens as we keep going across and across and across. So we get red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. So as you go across, the properties are not the same, but do you see how every time we start a new row or period, we get that same repeating pattern of the Roy G. Biv? So that's what periodic law states. Okay, so let me click back now real quick to where we're supposed to be. My clicks are going kind of slow, just bear with me here. Whoop, click too far. All right, so periodic law states that you have those repeating properties as you go across a period. Okay, so in columns, up and down, similar properties. Across, the properties are different, but they'll repeat if you keep going across. All right, so let's move on to breaking up different types of elements. We're going to start with metals, nonmetals, and metalloids. We'll break it down a little bit further in section 2. All right, so the periodic table can be broken down into metals, nonmetals, and metalloids. So if you look, they're color-coded on here. All the purple are metals, all the yellow are nonmetals, and the green are metalloids, which are sometimes called semi-metals. That's what it called it on here. I usually refer to them as metalloids. Where's my marker? There we go. All right, so there is a stair-step line that starts at, whoop. Well, that's a great marker. Ah, where's my good one? There is a stair-step line. Sorry about that. There is a stair-step line that starts at the top of boron and goes all the way over and down. The metalloids touch this stair-step line except for aluminum. Notice everything else that touches the stair-step is green and is a metalloid except aluminum. That's the only one that's a metal. So what you can notice from this also is that hydrogen is the only nonmetal on that side of the periodic table. Hydrogen does its own thing a lot. It kind of belongs in more than one place. We'll discuss that later. So you'll notice that a lot of times it's an exception and it has different things going on with it. All right, so the other thing I want you to notice is how many elements are metals on the periodic table. About 80% of the periodic table is a metal. Okay, so we have all the purple metals, we have our green metalloids that are touching the stair-step line, and we have our yellow nonmetals, including hydrogen. All right, so again, we'll break them down into more than this in section 2 because there are different types of metals and nonmetals and that type thing. All right, so let's move on and talk about some properties. So metals, properties of metals include that they're good conductors. That's why they're used as wires for electricity, conducting electricity. They are shiny. Okay, you see metals all the time. They're shiny. They are solid except for mercury. Mercury is the only naturally occurring liquid metal. Now, can we melt other metals and make it a liquid? Yes, but mercury is naturally liquid. There's actually only 2 elements that are naturally liquids. That's mercury and bromine, Br. All right, but bromine's not a metal, so. So they're solid except for mercury. They are ductile. Ductile means they can be pulled into wires. Again, hence the reason that they're used as wires. And then they're malleable. Malleable means they can be hammered into sheets. What you need to know about ductile and malleable is both of them means that we can reshape the metal without it breaking. Okay, Okay, you've seen it be hammered before, like in a movie when you see a blacksmith and they put the sword in the fire and it comes out and it's all glowing red, and then they bang on it with the hammer to shape it. Okay, so ductile and malleable means we can reshape the metal without it breaking. I can't sit there and take, a rock and start hammering it and reshape it into a different shape. It's just gonna crack. Okay, and so we'll talk about the difference in like metal versus like a different type of crystal structure called an ionic compound later, where those tend to shatter. All right, although metals are crystals, but we'll discuss all that later. It's just a different type. All right, so these are our properties of metals. Good conductors, shiny, solid except mercury, ductile, and malleable. So let's talk nonmetals real quick. Nonmetals, their characteristics they vary a lot more than metals. Metals, most of them are just a shiny, silvery color. A lot of them look alike. Like I could put 5 different metals in front of you and you probably can't even tell the difference in them if they're all the same color. Nonmetals, on the other hand, they have a vast difference between them. Like if you look at all these pictures I selected for nonmetals, that's why I have so many pictures on here, so you can see all the different properties. So nonmetals, they tend to be gases. You do have the one liquid, which is bromine, but not all of them are gases. So that's why I say they tend to be. There are some that are solids. They tend to be poor conductors, except for carbon. Carbon's a pretty good conductor. And so what I want you to notice is these are kind of opposite of the properties of metals. Instead of being ductile and malleable, which means we can reshape them, they are brittle. So if we try to reshape them, they're going to shatter. And then instead of being shiny like a metal, they're dull. So like I said, if you learn the properties of one of them, the properties of the opposite are just the properties of the other are just kind of opposite. So like you have argon, chlorine, let's see, what else argon, chlorine, and nitrogen, those are gases, okay? Chlorine's kind of like a yellowish green gas. You have bromine, which is naturally a liquid. It's kind of a reddish brown liquid. And then you have some solids, like we have carbon. It's in its black powder form right here. We have a sulfur crystal. It's a bright yellow. If I hit that with a hammer, it's not going to bend like a metal. It's going to shatter. We have phosphorus in its red form and its white form, which if they're both phosphorus but they're different forms, what is that called? Allotrope. And then we have iodine, which is a dark, kind of grayish crystal also, and again, it's not malleable or ductile. If you hit that, it just turns into a powder. It just breaks apart. All right, so these are some of the properties of nonmetals. So last, of course, is metalloid. Metalloids generally have some of the properties of metals and nonmetals. So for example, this is silicon, and I have some of this in my chemical room, so I can show you this in real life so you can see exactly what I mean. It looks like a rock that has been spray painted with metallic spray paint because it is shiny just like a metal. But if I hit this with a hammer, unlike a metal which will slowly bend, it just cracks just like a rock. Like I said, it's just literally so much like a rock, but it's shiny like a metal. It's really weird. Okay, and that's the way metalloids are, is they have some of both properties. Now they can't have two opposite properties, like it can't be a good conductor and a bad conductor, but it shares, some from each of the lists of properties that we discussed. All right, so let's knock out this section assessment. So what property did Mendeleev use to arrange his periodic table? Remember, Mendeleev, he used the mass. All right, he used the mass of the element to arrange his periodic table. All right, and then how are elements arranged in the modern periodic table? Well, in our periodic table, we of course use atomic number. Okay, we use atomic number. All right, number 3 says name the 3 broad classes of elements. Okay, well that's what we just talked about. What are the 3 types of elements? We have metal, nonmetal, and metalloid. Sorry, I'm getting out a better marker because that one's dying. So we have metals, nonmetals, and metalloids, which again are sometimes called semi-metals. All right. So number 4, it says, which of these sets of elements have similar physical and chemical properties? Well, where did we say elements need to be to have the same properties? They need to be in the same group, which is a column. Okay, so get a periodic table out if you didn't already have one out and start looking. Okay, oxygen, nitrogen, carbon, and boron. If you look on a periodic table, these are in the same period or row. So they would not have similar properties. So it's not A. All right, let's look at B. Strontium, magnesium, calcium, and beryllium. If you look at a periodic table, these are all in group 2. So since they're all in the same column, they're going to have similar properties. And then C look at nitrogen, neon, nickel, and niobium, these are just all over the periodic table. I'm pretty sure that these are just all choices that start with N, and that would in no way affect the properties. Okay, so it would be B because those are all in the second group. All right, so let's look at the last part of our section assessment. So it says, identify each element as a metal, metalloid, or nonmetal. Okay, so y'all, I'm going to draw a little periodic table up here for us. Hopefully you have your own out at home. Okay, so remember, the stair step makes up the metalloids. So what touches the stair step except for aluminum is a metalloid. Over here and down here, we have our metals. Okay, and then on here, this side, we have our nonmetals. And that's also including hydrogen is a nonmetal. And then remember, our stair step, except for aluminum, which is a metal, those are our metalloids. Okay, so all you need to do is look at where it is on the periodic table. All right, so gold, if you look on the periodic table, gold is about right here. So what is gold? It's a metal. Hopefully you knew that before you took my class. All right, gold is a metal. Next is silicon, that's Si. If you look, silicon is right here touching the stair step. So if it's touching the stair step, it is a metalloid. All right, sulfur.
Bolton, please come to the office. Micaiah Bolton, please come to the office.
All right, sulfur on the other hand is over here to the right of the stair step, so it would be considered a nonmetal. And then barium is right over here in group 2, so it would also be a metal. So y'all, just use that stair step as like a dividing point between the metals and nonmetals, but you gotta remember hydrogen is a nonmetal. And then you gotta remember what touches the stair step except for aluminum are metalloids. All right, and then last one, number 6, it says name 2 elements that have properties similar to those of the element sodium. Well, where can we find elements with similar properties? In the same group. Sodium is Na, which is in group 1 on the periodic table. So y'all, you can pick anything else from group 1. Now the only one I would kind of stay away from is of course hydrogen. Because remember, hydrogen is just, a little bit different than the other elements in that group. So if I was looking what's similar to sodium, I could put, I need to list 2, I could do lithium and potassium. And those would be 2 examples. Okay, so remember, common mistake that people have is the difference in a group, which is up and down, and a column, which is across. Elements in the same group, up and down, have similar properties. Elements in the same period, I think I just called that a column across. I'm just going to start over because I don't know what I just said. All right, so elements in the same group or column, which is up and down, have similar properties. Elements in the same row or period do not. Okay, so you cannot pick things in the same row. You need to pick things in the same group. Okay, so apologize if I confused you there at the end, but you know what? It happens.